Columbia. My thermal chimney kind of cracked about a third in, but it's still holding together. So what I did was inserted a 3-inch pipe into the cavity there, as you can see. Okay, the purpose of this test is to show you all the smoke that's coming out of the end. When I first started it up, there's quite a bit of smoke. But the purpose of this test is to see whether we can reburn the smoke in the same column. Normally, when you need a secondary reaction chamber to burn your wood smoke, but we're going to try to burn all the wood smoke in one linear source. So we're going to turn up the air and leave the propane the same. That pretty well does it. You're getting a complete reburn of the fuel. I'm going to back off the air again. There's your smoke. I'll be working with Wayne McCullough. He's the man who has an incinerator that can vortex rubber and anything that burns, oil, garbage. And he makes a pretty good head of, produces quite a bit of hydrogen in a secondary reaction system. And I'm hoping to maybe see if his device will be sufficient to power up like an 8-inch Joe pipe, and see if we can actually crack the hydrogen into H1 and 1, and going back, going to recombine back in the H2. The Joe pipe has kind of weird particularities, especially when you're pumping, using lots of force to push the reaction. If I had compressed air, I could probably put 100-150 pounds of PSI through this, and I do have a vacuum pump that I'm hoping to hook up to push maybe 500 or 600 CFM through the unit. We're going to crank it up here and take a thermal measure. I found that with the Joe pipe here, if you, I took this off, took the pipe out, and actually turned it into a tiger torch, I found that there's considerable change in the temperature. If a temperature drop, if you take the pipe off and just use it normally like a tiger torch. So we're going to take a reading here. We'll start with the pipe there. So this is just air temperature. You can see the titanium pipe is beginning to heat up from the back heat. And it goes off the scale once it goes in there. The fire is a lot hotter than 1100 degrees Fahrenheit. It doesn't register. So go to the front. We're going to start with the output exhaust. So we have a temperature 365. Coming up the output. We're going to move in. You see we're already over 400. We're still about 3 feet back from the flame. I have a piece of wood in there if you're wondering what's burning in there. 600. 700. And right at the end of the fire brick, we're already 960. You see the red dot there? 10. Say 900 degrees, 920, 925, 930, 930 degrees. So the thermal chase here definitely is helping to superheat the reaction, make it hotter than what you normally would get. Let's take a peek on the inside. Not too much volume coming out because it's hot. So this is an open kiln test. A little bit of light in between. It's yellow when you look at it by eye. But if you had more air going through it, definitely the fire would be turbocharged. So tomorrow or the next day, if I can get a blower going and see what happens when we push another couple hundred CFM through. So this shows me that the thermal reactor here is heating up quite hot, and burning the wood inside here shows me that if you pass smoke through here, it could be wood smoke, it could be tires, it could be rubber, it could be garbage that's going to crack in the reactor, in the thermal reactor. And by burning a piece of wood in there, that's proven the point there. See what happens when you crank it up. I don't think the air is on full yet. Give it a little more propane. I'm going to check the temperature again. See if it'll make 1100. Check the front first. Definitely rising temperature. 430, 440. Still climbing 450. Let's go back. Double there. Okay, right at the base. We're off the scale of the, only goes up to about a little over 1100 Celsius. So you know that the pipe here is as hot as, hot coals, right? Take a look on the inside. You have about another minute. Definitely an increase in the white point of the flame. Looking at it with the eye, you can see the white. So this thermal reactor is going to work to crack any kind of smoke. The pipe's beginning to turn red inside. It's still heating up. We'll probably come back on a part 2 on this. The thermal reactor is going to crack whatever you put through it. So you can use propane as a primer and pump all kinds of wood smoke through and use that for a secondary reaction. Still heating up. Let's see what our tip is. It's probably going to break 600 degrees at the tip. There we have it. We're off the charts.